Hello everyone. After understanding mass, density and weight, the basic properties, we also need to understand strength, hardness, toughness, what are these terms, how this relate to our industry. Okay, all those things we need to understand. Now, strength is nothing but the load which a substance can bear before it breaks. Okay, so generally, if suppose I have this substance, I want to break it, right? I will, if I am putting a tension force on it, that is we are pulling apart. Okay, the load it can take before it start breaking is nothing but your strength. Okay, so strength can be observed in your tension means when you are pulling it, compression, that's when you are pushing it, torsion when you are twisting it, or shear. Okay, so all these things we try to find strength at different loadings. Okay, now there is one more thing which is known as elastic modulus or modulus of elasticity or Young's modulus. Okay, now all these are the same thing. Young's modulus, elastic modulus or modulus of elasticity, all these are the same thing. Only thing is you need to remember that Young's modulus. Okay, Young's modulus is means, see, if you come across elastic modulus, Young's modulus of elasticity or modulus of elasticity, this is nothing but stress by strain. Okay, it is nothing but stress by strain. But if you come across Young's modulus, okay, this Young's modulus term you need to understand, this is tensile stress by strain, just tensile stress. Okay, whereas the modulus of elasticity can be compressive stress by strain and all those things. Okay, so now why there is a small difference, only small difference is here in Young's modulus you only take tensile stress because this was done by Thomas Young. This experiment was done by Thomas Young. He tried to understand how this steel will means what would be the behavior of steel under load. Okay, he tried an experiment and in that he applied a tensile load on the steel. Okay, and then he came across with the formula that modulus of elasticity or Young's modulus of elasticity is stress by strain. But in his experiment he applied only tension load, right? So that's why you need to remember it is tensile stress by your strain. Okay, so that is the only difference, otherwise everything is same between Young's modulus, modulus of elasticity. Okay, okay. Now then you also need to know more the modulus of elasticity, more the Young's modulus, more the strength it is, because it can take higher amount of stress and with small amount of extension or strain. Okay, so better it is, see, for diamond it has really high modulus of elasticity, and if for the steel it has a bit less than diamond, and if you go to different substance which has lesser strength, your modulus of elasticity would also be less. Okay, you also need to know that there is a standard value that is 2 into 10 to the power of 5, that is this value is Young's modulus of elasticity of steel. It might vary 2.1 into 10 to the power of 5 or 1.9 into 10 to the power of 5 depending upon the new, means what kind of steel are you buying, high carbon steel, or there are different kinds of steel. Okay, so but generally 2 into 10 to the power of 5 Newton per mm square is nothing but your Young's modulus of elasticity of steel. Okay, now we talked about what, in order to calculate strength you need to know Young's modulus of elasticity. Okay, higher the Young's modulus of elasticity, higher is the strength. Okay, the basic idea. Now so Young's modulus of elasticity or modulus of elasticity is nothing but stress over strain. Stress is nothing but force by area, which is Newton per mm square. Okay, and strain don't have any unit. Okay, because both are change in length by original length is strain, right? So it will cancel out each other. Okay, so this how you find out Young's modulus of elasticity is universal testing machine. Okay, now after that we also need to discuss about hardness and toughness. Okay, so what is hardness? Okay, so hardness of a material. Okay, so hardness is the ability of the material to resist abrasion. So if you scratch by your nail, if there are no scratching on the surface, that means it is hard. If there is a material, if you scratch it and there are scratches, then that means it is not hard enough. Okay, now most of the people what they will think is uh, more hard means more strength. Doesn't work like that. Okay, see, if you think that if the material is harder, so its strength would also be more. No, it's not like that. Why? I will tell you. If you take a marble, right, if you try to scratch your hand over it, okay, you will see no scratching on it. Okay, but if you take a metal, right, metal, not metal, yeah, metal, take a metal and try to scratch over it, soft metal, okay, to be soft metal, right, if you scratch over it, you will find that there would be some scratches on it. Okay, now why? So what we understood is marble is harder than the previous one. Okay, so marble is harder, but the point is the strength of that metal is more than the marble. Okay, that you need to understand. Okay, so hardness will make the material, if you make it more harder, it will become more brittle. Okay, brittle. The intermolecular means actually the material particles are arranged in homogeneous and isotropic format. Okay, so for that, this we will talk about in later classes, what is homogeneous nature of the material or what is isotropic nature of the material. But for now you need to understand, your more hard means it will slowly become brittle, and as the material becomes brittle, it has less strength. Take an example of chalk. Chalk is a brittle material, you can break it. Okay, so if you increase the hardness, it will become brittle. Okay, toughness. Toughness is nothing but how much energy it can absorb. Impact. Okay, so how you calculate toughness? By impact testing machine. Okay, so if there is an impact, how much energy it can absorb, the material can absorb, is nothing but its toughness. Okay, so these are the few things which you need to know: strength, hardness, and toughness. Okay. This is not so okay, fine. For now, just remember, modulus of elasticity gives you measure of the strength. Okay, strength is nothing but the amount of stress an object can take before failure. Okay, hardness is nothing but if the ability of the material to resist abrasion or penetration on its surface, and toughness is nothing but the ability of the material to resist impact, or the amount of energy it can absorb. Okay, so that is nothing but these three things you need to understand. We will also try to understand how it varies in different civil engineering materials in our next class.